Hi everyone, welcome back to my channel. So if you're new to my channel, please consider subscribing it and hit on the notification bell so that you'll be getting the notifications as soon as I release the video. So as for yesterday's class, we have discussed about what is HDL and what is Verilog HDL, right? So HDL is nothing but a hardware description language, and by using HDLs we'll be designing our hardware, we'll be designing the code for our hardware, right? So in this designing of the code, like whenever we are designing a circuit, first, as I already told you, we are using the HDL in order to write a textual format of that particular hardware, is it or not? So for this code, okay, whatever you are writing for this code, that means you are designing the code. Whenever you are designing something, you need some some category, like how to design this. You need some steps or some process in order to design this, is it or not? So in this way, in Verilog also, when you're designing the code, you can design it in two different ways. One is either top down design methodology and bottom up design methodology. So coming to what is this top down and bottom up, okay, before diving into the topic, let me give you a small example so that you can easily understand this thing. Okay, so let us consider you are designing some full adder circuit. Okay, so whenever you go for a full adder, what does the full adder consist of? Full adder consists of three inputs like A, B, C, and two outputs like sum and carry, is it or not? So basically, that is the thing that is needed for the full adder. So this is one step, this is one process. Like when you are designing a full adder, what are the things that you needed is the first step. And then again, if you could again categorize them, now coming to inputs and outputs, so let us consider output, sum and carry. Okay, what is the sum and carry of the full adder is? Sum is nothing but AX or BX or C, right? And for carry, it is nothing but AB, BC, and CA. So what does this basically consist of? Sum consists of sum or carry, either sum or carry consists of AND gates and XOR gates, is it or not? So again, we need to design in gates. So in this way, you are the methodology is categorized, so that if in this way, if you are going to categorize the thing, then you will understand how you should write the code and what is the code that is needed for that particular design. Did you get my point? So this is about top down and bottom up. So top down means, let us take an example of full adder only. So from top down means nothing but, if it full adder, if is the example, if is the design that you want to create, then in full adder, sum and carry are the sub blocks, and then again XOR gate and AND gate are the leaf cells. Okay, in this way the top down design methodology will be taken place. See here, in top down design methodology, we define the top level block. Okay, in our example, top level block is the full adder. Okay, and identify the sub blocks necessary to build the top level block. So in order to build the top level block, what are the things? Like in order to build the full adder, what are the things that you needed? You need sum and carry or ABC inputs, right? So these is the sub blocks, and again we further subdivide the sub blocks until we come to the leaf cells. Nothing but, if you can further divide them, right? For example, sum and carry, what does they consist of? They consist of AND gates, XOR gates, whatever it is, or gates, like that. So basically these comes under leaf cells. You can again further divide it. Like for example, let us take the AND gate. What does the AND gate consist of? Nothing but is the combination of PMOS and NMOS, is it or not? So that comes under the last, that means which are the cells where they cannot further be divided. You will divide them until the further can't be divided, or else you don't need them. Okay, basically when it comes to verilog, you only end with basic gates. You don't go for like nmos, pmos and all. Okay, so basically we will end at the gate level itself in case of verilog. Okay, I'm not saying it for any other thing, but in case of verilog we will be ending it at basic gates itself. Okay, we don't need further division of like nmos, pmos, cmos and all. Right, so this is top down design methodology. And the entire vice versa thing is bottom up. That means we will group the leaf cells and we'll build the sub block, and then we'll build the top block. Okay, this is about top down design methodology and bottom up design methodology. Okay, this is just like a, and this is the pictorial representation of this methodology. So if you see here, top block, and you are further dividing it into sub blocks and then leaf cells. Again, if you see the bottom up design methodology here if you see, the leaf cells are combined to fill the macro cell or it is sub block, and then again all these are combined with to build the top level block. So in this way, top down design methodology and bottom up design methodology, basically 90% of the designing that is done in the verilog is mostly done in top down design methodology, because it is easy to divide it in top down design methodology compared to bottom up. That's it. Okay, so the let us see the example here. Here see, if I want to design a 4-bit full adder. Okay, so this is the 4-bit full adder, and here, so since it's a 4-bit full adder, it consists of 4 adders like FA0, FA1, FA2 and FA3. So if you see here, every full adder consists of, you already know that, 3 inputs A, B, C and 2 outputs, right? So see here, this is how you will be categorizing it. Okay, this is first top block, and it is again subdivided into sub blocks like adder, 4 adders. Okay, now what does the adder consist of? See, carry and sum. Okay, every adder consists of both carry and sum. See here, A naught, B naught. This is the C naught and C in, and this is FA0, and this is S naught, and C1 is the output for this. In this way, 4 things. And now it is again further divided into, see, what does the carry consist of? What is the carry of the adder? It's nothing but AB, BC, CA. AB plus BC plus CA. So what is the consists of? Nothing but A dot B. Nothing but AND gate. AB plus. Plus is nothing but OR gate. Okay. Similarly, what does the sum consist of? Sum consists of XOR gate. Okay. A XOR B XOR C. Okay. So this is how basically the top down design methodology consists of. See here, some consists of ABC and some carry. Okay, consists of AND gate and OR gates, right? So this is how basically top down design methodology. And if you want to go for bottom up, everything is same, just the arrows will be like AND OR will be gathering AND and OR will be going for macro cells like carry and sum, and again cells, and then top block. Okay, so this is about uh, bottom up design methodology, top down design methodology and bottom up design methodology. And I'm giving you some other example, like let us consider a ripple carry counter. Okay, 4-bit ripple carry counter. Since it's a counter and it is a 4-bit, it consider. Okay, here we are designing a carry counter by using a T flip flop, right? So since we are using 4-bit, so 4 T flip flops, like see here, TFF0, 1, 2, 3, right? And it is designed with clock. So if you see the top down design methodology, so this is the ripple counter. So we want to design a ripple carry counter. Now, okay, we understood that. What is the thing that we needed here? 4-bit ripple carry counter. So from that we can understand that, and it is said that you need to design it by using a T flip flop, right? So now what happens? Okay, since it's a 4-bit ripple carry counter, now we should understand that, okay, it consists of 4 T flip flops. So we'll be dividing that like TFF1, TFF 1, TFF2, TFF3, and again. So how does the T flip flop will be designed? T flip flop is nothing but adding inverter gate to the T flip flop. So basically T flip flop consists of D flip flop and inverter gate. So by using this, now you may get doubt that why do we need all this. So basically, when you want to write a code for ripple carry counter, there is no particular code for writing the ripple carry counter, what do you need to do? You need to write a code for T flip flop and inverter gate, and you need to instantiate it with T flip flop, and then you need to copy this T flip flop gate, like you need to copy this T flip flop for 4 times. You will be knowing it when you further go into the further classes of this Verilog. Okay, so this top down design methodology or bottom up design methodology is for you to get an idea how to design a circuit, because it is just like carrying all the small pieces in order to carrying all the pieces in order to build a particular circuit. Okay, that means you will be carrying all these things like D flip flop, inverter gate, carrying all these logics and carrying all these sub blocks, and then you will be building the top block. Did you get my point here? So this is how top down design methodology and bottom up design methodology will be there in Verilog, right? And this top down, mostly I already told you, this top down methodology is the mostly used in Verilog. Okay, so this is about top down design methodology and bottom up design methodology in Verilog. Okay, in the next class we will be starting like modules and all, right? So this is all for today, and if you like my channel, consider subscribing it. Okay, thank you.